Um, this is kind of a simple unit or lesson. It's all about end behavior. So I've kind of been talking about that. Like if we sketch a graph, do they both go up? Do they both go down? Does one up and one down, one up and one down? So that's kind of what we're talking about today. So let's pretend we have this P of X, okay, and it's like a cubic graph. Okay, so what this means is you essentially, okay, you're looking at these arrows. Okay, what happens on the left, what happens on the right? Okay, and they judge that based off of the X values. Okay, so the left side is based off of the left side of the x-axis. So it says the x values are approaching negative infinity. So the beginning of this is called limit notation. And we are in pre-calc, but a lot of you might want to take Calc 1, Calc 2, multivariable calculus, like there's a lot more left after this, but you'll still see this notation, okay? So it looks like this. It says LIM for limit from x to, and then what does this x go to, the x-axis? What is that arrow pointing to?
Negative infinity.
Negative infinity. Fantastic. Okay? Negative infinity. That's just the beginning. Okay? That's the beginning. And so here, when you talk about the right side, that is limit of x to positive infinity, because that x is going to positive infinity. So that's the first part. Easy? Kinda, sorta?
Yeah.
Okay. Next, you take the actual name of the graph. So in this instance, it's P of X, and that goes next. And then, last but not least, you're going to have an answer. And your answer to this is how it's worded. What's the limit as x goes to infinity, negative infinity, your graph, this pink line, what's the pink line actually doing? It's going down. So that would be going down to negative infinity. So this really doesn't change. LIM, x to infinity, LIM, x to negative infinity, and then the name of the graph. Those don't change. What changes is what you put as this answer. And how you find that answer is you look at the graph of what's happening. And this one is going up to infinity. So this is like the very beginning. It's super easy. And what happens is they throw in asymptotes. Do you remember asymptotes?
Yeah.
Okay. So they'll throw in asymptotes, and then you'll have limits going all different places. Okay. So it does so as long as you just understand this part, it should be pretty easy. Okay, so we have a left side of the graph and we have a right side of the graph. Okay, left side is just talking about this side right there. And if my graph is going up and if it's going down, this is all we're talking about in this unit. We all know that this could like go down to 0, couldn't it? Like it could be a line where it like that exponential where it goes to 0. That is a case, but we're talking about just polynomials. So for polynomials, you'll either have one of these two blue lines. So if it's going, this is the left side of the graph. So you're going to have the limit of x to negative infinity. The limit of x to negative infinity. That's how every left side looks. And then let's say that this is f of x. And then it's going to change. So if it's going up, you're going to infinity. And if it's going down, you're going to negative infinity. And then kind of the same thing here. The big difference is that you're looking at the right side of the graph. And then you're going to have, it's either going up or down. So you're going to have the limit of x to infinity. Limit of x to infinity. And then of f of x would be up is positive infinity. F of x down is negative infinity. So those are your 4 options. There's actually 8, and we'll talk about it on the next page. But here's an example of an equation. Okay? Use the graph of f of x, shown at the right, and describe its end behavior using limit notation. So that's what it's going to say. End behavior. End behavior are my little arrows. Okay? Limit notation is this whole LIM thing. Okay? So we're going to start with limit of x to negative infinity. That is right here. As x goes to negative infinity, this is f of x. What does f of x do? Goes to negative infinity. Do you want a Jolly Rancher? Okay. Negative infinity. What color? Does that make sense? Where she's getting that from?
Yes.
Okay. So then, if you switch over to the other side, because there's 2 sides to the x-axis, as the limit of x to positive infinity, what is your equation doing?
Negative.
Perfect. F of x is going to, again, negative infinity. Easy, right? Okay? All right, now they want you to go backwards. Using the axis, right here, draw an example of a polynomial function that matches the statement. Okay, so how I like to do it is I kind of work by the sides first. So I look at this one. As x goes to negative infinity, so that's this line right there, my function is going to infinity. Do you see that?
Yeah.
So that means my function is going up. That's really essentially all it's saying. That my function is going to positive infinity. Okay, and then this one, as x goes to infinity, my function is going down to negative infinity. So it said, draw an example of a polynomial. So what do we know about this? What would this be? It could be what?
Negative.
It's going to be negative. Yep, it's going to be negative. Was that you, Isabel? Is that you? Okay, you know it's going to be negative, but you also know it's going to be an odd. Erilyn, was that you? Good job. It's going to be an odd. It's going to be x to the 3rd, x to the 5th, x to the 7th. So really it doesn't matter what the inside looks like because it didn't tell me. But I just know since there's one up and one down, okay, you know it's going to be one of those. And it's going to be odd because it's starting on the left and it's essentially going down, you know, like a negative line. Okay? Am I boring you? You like this? Oh, good.
All worth it for the while.
Yes,
I did
it's,
this all last year.
huh?
Like I just was just like a year.
Oh, you did limits last year?
No, but like and behavior, yeah. And behavior.
And behavior, yes.
But
Okay.
that's how we always wrote it, like as x goes to positive. Yeah. Y.
Yeah, we just didn't do the LAM notation.
Yeah,
Yes.
exactly.
You don't need a graph to describe end behaviors. You only need to recognize what?
The x y.
Close.
No.
So you look at the what?
If it's positive or negative?
Okay, and the exponent. I heard somebody say exponent. Miriam, was that you?
Yeah, blue face. I don't
Capri?
I didn't get a choice.
Thank you.
Okay,
Oh, no. Oh, right back to me. It's okay, I got water.
you look at the leading term.
Oh.
Which leading term, you guys are both right.
That was my next guess.
You look for the highest exponent and you look for the coefficient, okay? So in this instance, it's this one right here, this 7x to the 6th. So what does that tell us? What does 7x to the 6th tell us?
It's gonna be joined, because it's positive.
Okay, if the leading term has a what degree?
Positive.
Even degree.
Even, I'll take blue.
Even degree.
Hey, Luke. That was a
Oh,
right
sorry.
to the back.
The right side will behave
But I'll take blue one.
I said even.
I got you.
the same.
The left and right side will be the same. Okay? So when I was talking about like 8 different choices, okay, these are kind of the 8 different choices. So if it's even and positive, it's going to look like this. So me being my visual self, I like to just draw a quick little graph. What's it going to look like? And then I can do my limits based off of that, just so that I have a visual. So you're going to have a limit as x goes to negative infinity. And then this function is called p of x. So what's this one doing? Positive infinity. Fantastic. Because of this right here. But that doesn't come until the answer. Remember, this is still negative because this is talking about your x-axis. So you have 2 arrows. You've got the x-axis arrow and the function arrow that you're looking at. So then the limit of x to infinity, that's this side of x. P of x is also positive. Fantastic. Yes. So that's one instance. And then what if it's even but it has a negative
It's going down.
coefficient? Yep. It's going to be a parabola going down. So I'm always starting with this same limit notation. Limit of x to negative infinity of p of x. The only thing that you are changing is the very end answer. So sometimes this will already be written for you and it will have like a blank and you'll just have to fill it in, which is kind of nice, right? But you also need to know how to write this. That's why we're writing it 17,000 times. Because on the FRQs, they're going to ask for limit notation, and if you don't do it right, you'll get marked down. Okay? So these are both going to negative infinity, aren't they? Both arrows are pointed down. Both answers, so both function arrows. All right, next, if the leading term has an odd
Opposite.
degree, they're opposite. Fantastic. So if it looks like x to the third, x to the third starts low and goes high because it's positive. So the limit of x to negative infinity of p of x, and then the limit of x to positive infinity of p of x. So this one, negative infinity is negative, and then this one is positive. So these you get one of each, and then they just flip-flop based on the leading coefficient. So if it was negative x to the third, that's a negative sign. Negative, so that's going down. So the limit of x to negative infinity of p of x equals, and then this one is up here, so that's positive infinity. And the limit of x to infinity of p of x is negative infinity. How do we feel? Easy peasy?
Yeah.
Awesome. That's the extent that you will see on the test. Like it shouldn't be any harder than that. Yeah, so now, you can go back and work on 1.5 because I know that was quite a lot. And then 1.6 homework.